Hi, hello, vanakkam and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video we're going to see about the very first metric of performance engineering, and in fact this video is part of the performance testing to performance engineering transformation. So we're going to see about what is the first metric which you have to capture as part of your performance engineering, and that's going to be the TCP connection time. And the reason it is considered as a critical in performance engineering because of the first impression on the user experience. Because anytime when a website is loaded, the very first experience on the very first experience about the web application is mainly dependent on the TCP connection time. So now you know how critical it is for any web development or for any performance engineer, and the impact on the latency. So the amount of impact in terms of the latency is highly dependent on the TCP connection time. So we are going to discuss about all these topics, like why are we monitoring the TCP connection time as a critical metric in performance engineering. But before that, we'll see what is a TCP connection time and what is the importance of it and what are all the handshake technologies that are involved in defining the TCP connection. So we're going to see more and more about more performance engineering topics, and this is the second video on performance engineering. And coming back to our original plan where we were having a performance testing training, so there is another plan that is coming on. So please do catch up to subscribe. There are like several changes that is in progress, and I'm coming with all that announcements very soon. So coming back to this original topic, so the first thing that we're going to discuss today is the TCP connection time in performance engineering. So what is this TCP connection time is all about? So this TCP connection time, it actually refers, like it is mentioned here, it refers to the time taken to establish a connection between a client and the server using the TCP three-way handshake. So what is a three-way handshake? We'll see it now. So it mainly is when I say client, so it's your browser basically to the server, to the web server basically. So this is what the TCP connection is all about. So the time taken to establish the connection between the client, that is you, and your server, that is your end server, using the TCP three-way handshake. So this handshake actually involves three steps. That is, it starts with synchronization and synchronization acknowledgement, and then finally the acknowledgement, the client acknowledgement. So when I say about the synchronization, so the client sends a synchronization packet to the server to initiate a connection, right? So that's the very first action. It's the very first action that any request does. So it actually, the client will send a synchronization request, a synchronization packet to the server to initiate a connection. And the second action is the server acknowledges the synchronization and sends a synchronization acknowledge packet back to the client. And then thirdly, the client, that is you, your browser, acknowledges the server's synchronization acknowledgement packet by sending an acknowledgement. So all these three happen. So it starts with the synchronization packet, and then it gets acknowledged. It actually acknowledges the synchronization packet by sending a synchronization acknowledgement packet back to the client, and then thirdly, it is the client. Finally, the client acknowledges the server's synchronization acknowledgement packet by sending an acknowledgement. So all these three has to happen to establish the connection time. So this is the three-way handshake that I'm talking about. And then the next part. So what is the next thing? So initially, now we saw what is all about the TCP connection time. So let me just quickly explain. So the TCP connection time. So this, in fact, you will need if even in your performance testing and mainly in your performance engineering interviews or in your knowledge sharing. So all that TCP connection time is the time taken to establish a connection between a client and the server, right? And then what is the importance or why this metrics is important in performance engineering? Because we know there are several other, there are like a lot of metrics, we all know, right? In performance testing, we know like the response times, the throughput, the hits per second, lots and lots, like average, minimum, maximum response times, whatnot. But why this TCP connection time is considered as the very critical metric in performance engineering? So let me give you a quick manner. So in performance testing and engineering, TCP connection time is a critical metric because it impacts the overall latency of a request response cycle. So a high connection time can result in a slow application performance and it will automatically degrade the user experience. So that is the reason we do have to worry about the TCP connection time. Like I'm telling you again, so high connection time, which is a connection time that is very longer, will result in a slow application performance, because just imagine your synchronization packet takes a lot of time to reach the server, and then the server sends back the synchronization acknowledgement packet again back to your client, and it takes a lot of time. And then finally you imagine your acknowledgement packet, the final packet which you send, which you acknowledge from the client side, will again actually take like too much of time. So just imagine how much time does it take, which just like high connection time will actually result in slow application performance, and it will automatically degrade the user experience. So now we'll see what are the factors that influences the TCP connection time. So the first thing is, yes, as we all talking about, the latency, that is sending your packet, receiving it back, acknowledging it, and sending back and forth, right? So the first thing is the network latency, so the round trip time. So that's why we normally talk about the latency in terms of response times, in terms of increase in response times. Yes, latency actually plays a major role, because the round trip time, which we normally call as RTT, between the client and the server, affects how long the three-way handshake takes. Yes, that's why I'm telling you how important it is to measure the TCP connection time as the very first critical metric of performance engineering. And second thing is the server load. So a heavily loaded server, yes, will have delay in responding to connection request, which in turn will increase the connection time. And thirdly, the network congestion. So congested networks can lead to packet delays or drops, which will affect the connection establishment. And then the firewall or proxy overheads. So the security devices like firewalls or proxies may introduce delays during connection setup. And finally, the geographical distance. So physical distance between the client and server impacts the RTT, that is the network latency, and consequently the connection. Just imagine you are situated somewhere in UK, and your server is placed somewhere in Singapore. So the amount of physical distance between the client and the server, yes, it takes a lot of time, and it will definitely automatically it will impact the RTT, that is the round trip time, right? So that's the reason geographical distance is also another factor that influences the TCP connection time. Okay, so now we'll move to the next part, which is why should we measure the TCP connection time, the very first metric. So why should we need to measure it? So the first thing is the baseline performance. So to establish a benchmark for connection times under normal conditions. So under normal conditions, yes, we have to establish a benchmark, and then we have to have the response time. So what is going to be the performance of the application under the normal conditions, and then the network optimization. So we have to identify and we have to address the network related bottlenecks. And thirdly, the troubleshooting. So we have to diagnose issues in slow applications by isolating delays in the connection phase. And finally, the capacity planning, where we have to ensure servers that can handle expected loads without excessive connection times. That is all about the measurement of TCP connection time. So let me quickly reiterate. So to measure the baseline performance for the network optimization, where we have to identify and address network related bottlenecks. And thirdly, for the troubleshooting, where we will diagnose the issues in any slow applications by isolating the delays in the connection phase. And finally, the capacity planning, where we ensure the servers can handle expected loads without excessive connection times. So these are the reasons why do we measure the TCP connection time. And now the next part is how are we going to measure the TCP connection time. So far we saw about why do we measure the TCP connection time, and we saw about the factors influencing the TCP connection time. So now we'll see about the how to measure. So first thing is, yes, we have to use tools, because although we can do it manually, but using tools will actually get us the exact timing, the exact numbers. So you can use tools like JMeter, the K6, LoadRunner, or even Wireshark that can capture, and we can analyze the TCP connection times during performance tests. And in JMeter, yes, that is typically logged as part of connection time in the results. And then the monitoring metrics, where we have to look for connection metrics in application performance monitoring tools, like mainly like APM tools like Dynatrace or App Dynamics or New Relic. So we can use all these tools, the monitoring tools, the APM management tools. to measure the TCP connection time. Yes, we can actually look for the connection metrics there. And then the next part is we have to, we are going to see about the best practices. So what are the best practices that you have with your, or what are the best practices that can make your application better in terms of the TCP connection time. So coming back to the best practices, the first thing is we do have the reducing of network latency. So which is we can use the CDN, which is content delivery networks, to serve the static content closer to users, and then we can optimize the routing and avoid unnecessary hops. So when I say using content delivery to serve static content closer, so which means like you can actually have the servers, right? So where we can use them to serve the static content which are very closer to the user, so that the time for synchronization or acknowledgement does not take too much of time, so the users will have a better experience in terms of the application. And then when we optimize the route and when we avoid unnecessary, when I say unnecessary hops, so there will be like multiple hops, which is like even before we reach the server from the client, we do have multiple systems where the connection goes on and on and on. So instead, if we have like minimum number of hops between the client and the server, then yes, automatically there will be a reduction in network latency. And then optimizing the server configuration, where we can tune the server to handle more concurrent connections. Yes, this will automatically improve the performance, and then we can use keep alive settings to reuse connections. And then when we scale, we can actually scale the infrastructure by using the load balancers to distribute the incoming requests. We can also scale the servers horizontally to handle peak load. So either you have to scale up or you have to scale out, right? So in this case, it's mainly the point here is scaling your infrastructure, and then by monitoring the infrastructure regularly. So by continuously monitoring and by analyzing the TCP connection times during performance tests and in production environments. And then the next part here is overall for response times. Yes, we do have an SLA, that is a 3 second of response time, right? Yes, that's what we all have in our mind. So where we always wanted our application to be anytime less than 3 seconds or even 1 second or even 5 seconds. So we do have an SLA. So what is the SLA for the TCP connection time? Yes, even TCP connection time also has an SLA or an acceptable limit. So in terms of TCP connection times acceptable limit, actually the time depends on the application and the infrastructures as well, where a typical threshold for a good performance is around 100 milliseconds or even lesser, but it should not go beyond 100 milliseconds, because this 100 milliseconds will add to your response times as well. So that's the reason we have to keep this 100 milliseconds as the minimum, the maximum one in any optimized environment. So for applications with global users, it might be slightly higher due to the geographical latency. Like an example I told you, like where a user accessing from UK to Singapore location, yes, there will be an increase, or there will be an increase in latency. It's all because of the global presence. And so after all doing all these, so by regularly monitoring and optimizing the TCP connection time, we can ensure that we have an efficient and responsive system performance by contributing to a better end user experience. So this is the very first metric that we have to collect in terms of performance engineering. So going forward in our next videos, we'll see what are the other metrics that you're going to collect, and why do we need to collect, and what is the what are the factors that are involved in it, and how to do that. So we will see all these in our next video. So until I meet you in our next video, it's bye bye from Asan Shanmugam and your favorite Little Slaw YouTube channel. Take care and bye bye.